Let's see. Hi, everyone. Thank you for tuning in. I just wanted to come online to see if anyone had any more questions on the test review. Maybe you were working through some and found out you needed some help or clarification on any of the questions. If I have already worked through the problem on Friday, then I'll just tell you to reference that other video from when we did our 5 o'clock session before the weekend. So I'll try to only work out problems that we haven't already worked out on this video feed. So if you have any questions, remember you can chat on the Google Classroom, or if you're logged in with a non-student account, you'll actually see the little chat off to the side where you can leave your questions there. So, did you have any problems as you were working through the test review? You have any questions about model drawing or setting up place value charts? I can answer all of those questions right now. Anybody? Let's see. It was raining quite heavily earlier, so I chose not to drive to school. So we have a little setup at home. Let's see. If there's not any questions, what I can do is I can just work out problems that I didn't go through the other day, and we can just keep going with that. I think last time I skipped number 4, so we can look at that now. Let's see. Just make sure there's no questions, and if there's not, then I'll just move on. Okay, so we're going to start with number 4, and it was the question about fudge. Let me just switch over here so I can see real time. So number 4 was right here. If I got paid $1 for every time Fudge looked at my turtle, I would be a rich man, said Peter. He decided to actually record the number of times Fudge looked at his turtle in a day. In the morning, Fudge looked at the turtle 384 times. In the afternoon, Fudge looked at the turtle an additional 1,239 times. In the evening, Peter counted 683 glances. How much money would Peter have been paid if his statement right here were true? So, he wanted to count up the total number of times Fudge looked at his turtle all day. Okay, so the question was, how much money would Peter have been paid? Well, if he got $1 for every time Fudge looked at, excuse me, for every time Fudge looked at the turtle, then it would be one glance is $1. Okay, so how can we answer that question? How much money would Peter have been paid? Peter would been paid blank dollars. We don't know yet how much money he would have been paid because we haven't figured that out yet. So let's see here. How did he record the number of glances? He reported some glances in the morning, some glances in the afternoon, some glances in the evening. And in a full day, how much would he have recorded total? So what we've got is we've got to record his morning glances, his afternoon glances, and Fudge's evening glances, okay? And if we get all those numbers together, we would get a total. Okay? So how many times did Fudge look at the turtle in the morning? Well, it says right here, Fudge looked at the turtle 384 times. So we can fill in our model drawing, our strip diagram, 384 right there, okay? Then, in the afternoon, Fudge looked at that turtle 1,239 times. And in the evening, Peter counted 683 glances. So that's here, 683. So what do we do to find the total? We're just going to add them up. But remember, when we're adding numbers, especially whole numbers, and actually any numbers at all, we need to make sure that we're going to be lining up the place values, okay? So all the ones need to be lined up, the tens, the hundreds, and so on. So let's line them up. We've got 384, 1,239, and 683. And we need to add them up. So it is an addition problem. So let's add them. 9 plus 4 is 13. 13 plus 3 is 16. So we know we can't write 16 here, but we can write 6 and regroup that 1. So that is 9. 9 plus 3 is 12. 12 plus 8 is 20. Regroup the 2. 5. 3 plus 2 is 5. Plus 2 is 7. 7 plus 6 is 13. And then 1 plus 1 is 2. So when we combine all those numbers, we end up getting 2,306. Well, what does 2,306 mean? It's the total of all of the glances Fudge took with, Fudge looked at the turtle that many times. So the total is 2,306. Well, how much money would Peter get paid if Fudge looked at the turtle 2,306 times? It was $1 for every glance. So he would be paid $2,306. Okay? And there's our solution. And I went through number 5 on Friday, but let's look at number 6. Let me grab an eraser real quick, because this one's not going to work. I'll be right back. Okay. So let's go on to number 6. Actually, let me double check to make sure there's no questions. Let's see, I don't see any questions on YouTube. Let me refresh this right here. Okay, I don't see any new questions here. All right, that's okay. So we'll just keep going. If at any time you want to see it again, you might have to wait a little while, but once the stream gets uploaded onto YouTube as a regular video, you can rewatch it as much as you want to. So let's see here. Let me back. Here we are. Number 6. Since we already solved number 5 in the last video, let's go to number 6. Whoops, can't see. Owen lives 145 and 25/100 kilometers from Houston, Texas. Sharon lives 209 and 5/10 kilometers from Houston. What is the difference between these two distances? Okay, so there's our question. Let's frame up our answer. What is the difference between these two distances? Okay, so let me get up. The difference between is blank kilometers. Okay, so we know that's between. KM is an abbreviation for kilometers. Okay, so we use the wording from the question in our sentence frame so that we make sure that whenever we're finished, whatever we fill in is going to make sense. Okay, use as many words as you can, be as descriptive as you can to make sure that you are actually answering the question. So let's look at this. We've got Owen and we've got Sharon. This one is a little bit different than the other ones that we've solved up until now. So it's asking for the difference, but it's not talking about anything like a total or anything like that. So when we talked about total, we knew that two numbers would have to be combined to get a total. Well, here it gives you two distances or two numbers, and it's asking you to find the difference, okay? So our model drawing is going to look a little bit different. So in order to show the difference, what we're actually doing is we're comparing two numbers, okay? So let's look at Owen. I'm just going to use O for Owen. Owen lives 145 and 25/100 kilometers. So his is this. Okay. And then Sharon lives this far. Hers is a little bit more. Okay. And she lives 209 and 5/10. Okay. I'm going to write that off to the side. Okay. So what is the difference between these two distances? Okay. Sorry for the glare. This is 209 and 5/10. Okay. So how do we find the difference? Well, when I compare these two distances, I can see that one is more than the other. Well, how much more is Sharon's distance than Owen's distance? Well, if I can show that from here to here from Sharon matches from here to here with Owen, I know this is at least 145 and 25/100 of a kilometer. And then there's this little distance that I don't know. So the portion of her distance that is more than Owen's is the piece that we're going to try to figure out. So the piece that's more than Owen's is going to give us the difference between the two distances. Okay, so how do we find that difference? Well, I know to get 209 and 5/10, I need to take 145 and 25/100 and add it to something to get that. Well, how do I find that missing piece? We solved it before with other problems. When you're trying to find the missing piece in an addition problem, you can subtract to get this one last piece. So let's subtract. Here we've got decimals. Do you remember what we're supposed to do when we add and subtract decimals? I hope you remember. What are we going to do? We need to make a place value chart. Okay, so let's get in with the place value chart. Let me just focus here. Okay, so I've got 3 place values ahead of the decimal, 2 place values behind the decimal. So here's my decimal right here. Ones, tens, hundreds, 1, 2, 3 place values. Then I'm going to have my tenths and my hundredths. Okay, so 3 place values ahead of the decimal, 2 place values behind the decimal, and that should cover all of my digits that I've got. Okay, so I need to do a subtraction problem. So I'm going to start with this one. Take away 145 and 25/100 to get this piece. Okay, so let's make our place value chart really quick. $209 and 5/10, and then 145 and 25/100. We're going to subtract. So let's subtract. Oh, there's nothing there. But what can I fill in? I can fill in a 0. Okay, so now everything kind of matches up. All the place values are lined up. So let's do our subtraction. If I have nothing, can I take away 5? No. So I need to regroup or borrow. So this is going to become a 4. So when we take 1 away from the tenths, we can add 10 here. So that's going to make this a 10. 10 take away 5. Now we can take away. 10 take away 5 is 5. 4 take away 2 is 2. Don't forget our decimal. 9 take away 5 is 4. 0 take away 4. If I have nothing, can I take away 4? No, need to regroup again. So this becomes a 1. This one becomes a 10. 10 take away 4, that's 6. And then 1 take away 1 is nothing. So you don't have to write anything here, but you can write a 0 if you want to. So the difference, after we subtract, the missing piece that we found is 64 and 25/100. So let's fill that in here. If we really wanted to check, we could take these two numbers, we could add them, and we would get this, okay? So if you want to check to make sure that your math is correct, you can add these two numbers back to double check that you subtracted correctly. But that missing piece right here, that's going to be the difference between Owen and Sharon's distances. And so then we can fill in this blank right here. Okay, and there's your solution. So for what number was this? This was number 6. So the difference between the two distances is 64 and 25/100 kilometers. Okay? So again, with the model drawing, just make sure it's extremely important for you to use this step in your planning so that you can see what operation needs to be done. If you were rushing through the problem and you were just grabbing numbers from the actual story and adding them up, then you would have missed the fact that you needed to find the difference. Okay, how much more is Sharon's distance than Owen's distance? That difference right here is found through subtraction. Okay, so let me get rid of this. We'll go on if there's no questions. Okay, let's see. Let's look at number 7. Oops. Number 7. On Monday, Sophie and her family drove 113 miles to her aunt's house. On Friday, they drove 185 miles to her grandmother's house. And on Sunday, they drove 328 miles home. About how many miles in all did they drive on these days? Okay. There's a word right there that we really need to focus on. As we're setting up the problem and the sentence frame, think about this word right here. About how many miles? Okay. Let me double check there's no questions. Try to build a sentence frame based on that question and see if you can come up with what we're about to come up with here. Okay, it says, about how many miles did they drive on these days? So, if we're going to answer the question, remember we always frame up our answer first with a sentence. Let's use as many words as we can in the question in our answer so that our work will make sense. About how many miles in all did they drive on these days? Let's see here. They drove about, okay, we're going to use as many words from the question as possible. So they drove about blank miles. In all. Okay? So in all of those days, about how many miles did they drive? Well, what are the days that they drove? They drove on Friday. They drove on Monday. Started with Monday. Sorry. They started on Monday. They also drove on Friday. And they also drove on Sunday. Okay? So in all, about how many miles in all did they drive? Well, in all suggests you need to see how much they drove on all 3 days combined. Okay? So we're looking for a total. Okay? But we pointed out this word when we first started. Have you thought about what that means? What does the word about mean? About means you probably don't need an exact answer. They just want a general number. So remember our conversation about when nobody really cares about the exact answer. What should we do? About tells us that we need to round and estimate. Okay, So let's look at this. What is the best way to round and estimate so that we can get to our answer quickly? This is one of the mental math strategies that we were talking about probably about a week ago. There were 3 mental math strategies. One was making 5, the other one was making 10, and then the last one was rounding and estimating. Okay, we talked about the height of the Empire State Building, how nobody really cares what the exact measurement of it is. They just want a general number because we're just having a casual conversation. So maybe Sophie was talking to somebody about how much they had driven to go to all these people's places, go to visit all these family members. And so whoever she's speaking to could say, whoa, well, about how many miles did you drive? Well, nobody has the time for her to pull out pencil and paper to add it all up. Nobody really cares exactly how much because they're not going to be making that drive. So the best thing she can do is to estimate so that she can add quickly in her head. Okay, so if I look at 113, what's a good number we can round to so that we can do some mental math? 113 is about 100. Okay, we're thinking it's about 100 miles. Okay, that's pretty close. And then this one, 185, how much is that? Well, that's about 200. Okay, it's closer to 200 than it is to 100, so we're just going to go ahead and use 200. This little squiggly line, that's our notation to say about this number. Not exactly, but it's about that much. And then the last one, Sunday, they drove 328 miles home. Well, what's the fastest way to give an estimate for 328? It's around 300 miles. Okay? So, if we rounded each number first, we can quickly add those up in our head. We don't need pencil and paper. So, what's 100 plus 200 plus 300? Well, I can just add these digits really quick. 1 plus 2 is 3. 3 plus 3 is 6. So the answer is about 600 miles. Okay? Now, I looked at some of your work when you were doing your task cards. A lot of you chose to add it first and then round. And that would be all right if you had pencil and paper. But remember, in casual conversation, we don't always have our math tools in front of us. So if you can do this in your head, rounding first makes the math a lot easier. Okay? So 600 miles, they drove about 600 miles. And that's a quick way to give an answer without really having to do any math. Okay? A little bit, but not too much. And remember, this is when somebody doesn't really care about an exact answer. That person isn't going to make the same drive as Sophie, so they just wanted to know about how far is it. Okay? Let's see here. Okay, I see Emilion is very active in our chat today. Very good. I like your participation. Okay, Sarah, I see you've tuned in. We are currently on number 7, but I just finished it, so we're going to move on. If it seems like I skipped some problems, I probably did because I've already solved them on Friday. So if you don't see a problem being worked out right now, you can check back the live stream from Friday, and you'll probably be able to fast forward and find where we solved it before, okay? So I'm going to go ahead and get rid of this so that we can solve another problem. Remember, if you see that word about, we're not looking for an exact answer. But be careful when you're reading. Okay? That's why the sentence frames are so important. If you are really good about using as many words as possible from the question in your sentence frame, then you can catch it a little bit more easily, okay? So I'm going to go ahead and move on. We're going to go to number 8, okay? Number 8's right here. So where's my marker? Number 8. Jennifer has 3 2/10 liters of orange juice. And yay for us, the problem actually gives us a model, okay, or a picture representation. If Jennifer drinks 3/10 of a liter of orange juice, what will be the amount of orange juice she has remaining? Well, if this was on your paper, she's going to drink 3/10. So what does that mean we have to do? She's drinking 3/10. Let's see if you can determine what we're going to do. I'm going to go ahead and just copy the model onto the board here so that we can look at it. Okay, and let's see. Okay, the whole thing is filled in here, and all right, so I colored these quickly just because those two are completely filled in, and then these, if you can count on your model on your paper, what are these divided into? Each block is divided into how many pieces? Well, you can count them, or maybe you already know because you're familiar with this model. If you count, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each block is divided into 10 pieces, okay? So we've got 1 whole, 2, 3 whole grids filled in, and an additional 2 pieces out of 10. Well, we read that fraction 2/10, but it's also a decimal, which is 2/10, okay? So, if this is how much juice she had, let's look at the question. What does the question want to know? What will be the amount of orange juice she has remaining? So how do we answer that question? Use as many words as you can. She has blank liters of orange juice remaining. Okay? So, as Emilian said, yes, we do need to subtract. So if she has this much, but she drinks some of it, then we do need to subtract, take some away, okay? So she started with 3/10. Oh no, sorry. She started with 3 2/10 liters. This is how much orange juice she started out with. This is how much she started out with. But she drank some. She drank some. So we're going to subtract that and then find out how much does she have left. Well, if you've got this model here, you can subtract it on the model by either crossing it out or getting rid of 3/10. There's 1/10, 2/10, 3/10. Okay? So then you can, from your picture, count, well, how much is still colored in? Well, I've got 1 hole, 2 holes, and then I've got, how many tenths here? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9/10 remaining. So that's 2. Here's 2. And here's 9/10. 2 and 9/10. This one we erased everything, so she doesn't have that anymore. 2 and 9/10. Well, how do you write that in decimal form? 2 and 9/10. 2 and 9/10. Okay? You can do a place value chart. Ones, tenths, hundredths if you want to, but it's just split into tenths, so you wouldn't really use it. Okay? 2, that's a whole number. And, the decimal says and, 9/10. Well, here's your tenths. So you can fill in your 9 here. And there's where your number is. Okay? So that matches what we've written up here. 2 and 9/10. Okay? Well, how do we do it with, if we didn't have the model and we wanted to show it another way, we can show subtraction by, let me just kind of get rid of this and I'll show you the place value chart. We're going to start with 3 and 2/10. And she drank 3/10. Okay? So we're going to subtract it. If we have 2, can we take away 3? No, we need to regroup. So this one's going to become a 2. And then you're going to add 10 here. So that becomes 12. 12 take away 3. We can do that now. 12 take away 3 is 9. Don't forget your decimal. 2 take away nothing. Okay, there's nothing here. 2 take away nothing is 2. And there you have 2 and 9/10. That's how much is remaining. That's how much we saw in the picture. Here. Okay, so she has 2 and 9/10 liters remaining. Okay, remember, when we're subtracting decimals, make sure that you're using a place value chart so that everything lines up, especially that decimal right there. Okay, once you make your place value chart, the decimal doesn't get to move wherever it wants to. It has to stay between the ones and the tenths, always. Okay, so let's see if we have any questions. Very good. Okay, so that was number 8. I'm going to go ahead and get rid of this so we can move on to the next problem. Let's see here. Okay, let's move on to number 9. Inez is 12 years younger than Raul. Raul is 6 years older than Kaylee. Kaylee is twice as old as Henry. Henry is 5 years old. What is the combined age of these 4 people? Well, let's go ahead and frame up our answer. This is number 9. Use as many words from the question as you can. Okay, the question again was, what is the combined age of these 4 people? So you can write the combined age of the 4 people is blank. Okay, so right off the bat, in the question, it says combined age. Okay, so when you're combining, that should give you an idea of what kind of operation we're going to be dealing with. Okay, so let's see here. Who are we dealing with? We've got 4 people, and we have to figure out how old everyone is before we can add them together. Okay, combine, add. But let's look at each of these kids. We've got Inez, we've got Raul, we've got Kaylee, and we've got Henry. Okay, so we know Inez is 12 years younger than Raul. Okay, so if she's 12 years younger, her age is going to be smaller than Raul's. We don't know how old Raul is yet. But we know that if we knew Raul, what would we have to do to figure out Inez? She's younger. How much younger? 12 years younger. Okay, so Inez is going to be 12 years younger than Raul. So we're going to take Raul's age, we're going to subtract 12, and that's going to give you her age. We don't know Raul yet, so right now we can just leave it like that. Raul, here's where it talks about Raul's age. He is 6 years older than Kaylee. So if we knew how old Kaylee was, we knew that Raul's age is a little bit more. How much more? 6 more. He's 6 years older than Kaylee. So we're going to take Kaylee's age and we're going to add 6. But we don't know her age yet. So we're just going to leave Raul like this. Well, let's read about Kaylee. Kaylee is twice as old as Henry. So whatever Henry is, it's going to be Henry 2 times to give you Kaylee's age. So whatever Henry is, we're going to go ahead and, if Henry is this old, Kaylee is at least that much, but she is twice as old, okay? Let me try and make them the same size. 2 times what Henry is. But here, Henry, it tells us exactly how old Henry is. How old is Henry? He's 5 years old. So very good. We know Henry is 5 years old, so now we can go backwards. Well, Kaylee is 2 times whatever Henry is. Well, how old is 2 times Henry's age? You can add it twice, or you can just multiply. 5 times 2 is 10. Okay, so Henry is 5. Kaylee is 2 times his age, which is 10. So now that we know what Kaylee is 10. So if Kaylee is 10, how old is Raul? Raul is 16. Well, now Raul, take away 12 is going to give you Inez's age. Well, 16 is Raul's age. Take away 12. How old is Inez? Inez is 4. Are we finished? We know the 4 ages of the 4 people, but If we return to our sentence frame, the combined age of the 4 people is, we're not done yet. Again, the importance of framing up your answer at the very beginning so that you know when you're finished with your work. It doesn't care about Inez's age. It doesn't care about just Raul's age or Kaylee's age. It cares about everybody's ages combined. Well, what do we do to combine their ages? We have to add them up, okay? So we've got 4 plus 16 plus 10 plus 5. Let's add those up. Well, that makes 10. 10 plus 5 is 15. 1, 2, 3. If we combine the 4 people, their combined age is 35. Well, that's what the question was asking. The combined age is 35. Okay? So, when you've got an age problem like this, or 4 people and they give you riddles for each person, just do your model drawing like this. Write everything out so that you know how to get back to what the original question was asking, okay? It's almost like this was 5 problems in one. That's a lot of steps. You can't possibly do all of your steps up here, so go ahead and write it down, okay? Nobody's punishing you to take up too much room on your paper. Use as much room as you need to. And on Monday, I'll give you tons of scratch paper so you can work the problems out, okay? No big deal. So that was number 9. What we're going to do is we check for questions and then see if we need to move on. Okay. Sarah, however you're studying, you can write down on your piece of paper whatever you want to. You can work out the problems as I'm working them out. You can watch it now and see if you can solve it later and watch the video again to check. So whatever you think is best to prepare or to make sure that you know how to solve these problems, you can decide, okay? So remember, I'm not making you turn any of this in. This is just our way of helping you prepare for the test. So how do you prepare? Do you try to work out problems on your own? Are you just watching? Okay, the best way to practice is to try to do things yourself. Okay, so whatever strategy you think is best, go ahead and use that strategy. Okay, let's see here. Go back. So let me go ahead and get rid of this so we can move on to the next problem. Okay, we solved number 10 on Friday, so I'm going to go ahead and move to number 11. Number 11, one number has 4 thousands, 12 hundreds, and 0 tens. Another number has 4 thousands, 6 hundreds, and 5 tens. What are the two numbers, and how do they compare? I feel like we worked through this problem already too. I'm going to go ahead and skip that one, but go to Friday's live stream. You should be able to find that problem there. I'm pretty sure I worked through both number 10 and 11 on Friday. Well, let's go to number 12 then. Oh, I feel like I worked out number 12 too. Sabrina rounded the size of the... Oh, we did that one. I remember. Okay, so let's do this one. Number 13. Okay, each picture below represents a different amount of money. In which amount of money is the digit 9 in the hundredths place? Okay, now remember the place values for money transfer to regular number place values. Okay, in money we have dollars and dimes and pennies. In regular numbers we have ones and then tenths and hundredths respectively. Okay, so let's look at each of these answer choices. We've got to figure out how much money is each answer choice. Let's fill it into a place value chart since that's good practice. Let's do dollars, dimes, pennies. And right away, you can also write the other name for that place value. This is ones, this is tenths, and this is hundredths. And what number is this? This is number 13. Okay, so if you can do your place value chart like this, then you should be good to go when you're filling in everything. You know the ones is the same as the dollars, tenths is the same as the dimes, hundredths is the same as the pennies. Well, the question is, in which amount of money is the digit 9 in the hundredths place? So we're going to be focusing on this to find which one of those, A, B, C, or D, has a 9 right here. Okay? So, there. Let's do A, B, C, D. Okay? So let's look at this. On A, I see a $5 bill and 2 ones. $5, $6, $7. How much change is that? I see 3 quarters. So that's 75 cents. Plus a dime, that's 85 cents. Plus a nickel, that's 90 cents. 95 cents. 96 cents. So $7.96. Okay, so we know we're looking for a 9 in the hundredths place. A 9. This one doesn't have a 9, so we know that's not the one. Okay, so let's move on to B. B's this one down here. I've got 4 $1 bills. So that's $4. And we've got hold on. A was 75, 85, 90. I'm sorry, that's a penny. 92. Still wrong, but sorry about that. I'm blind. Here we go. This one is a quarter, 25 cents, and we've got 2 nickels, 25, 30, 35, and we've got 4 pennies, 35, 36, 37, 38, 39. Okay, there's a 9 in the hundredths place, so maybe that's the one. Let's just check, okay? Let's look at C. That's $3. $3, and we've got 2 quarters. It's 50 cents. 2 quarters, 2 dimes, 50, 60, 70. 2 nickels, 70 plus 75, 80. And then 3 pennies, 83 cents. Okay, that one doesn't have a 9 in the hundredths place, so we know that's not one of them. Let's check D. Oh, I've got a $5 bill. $5, $6, $7, $8, $9. Okay. And then I've got 2 dimes here. That's 20 cents. 20 cents plus a nickel. That's 25 cents. 26, 27, 28. Don't forget my decimal. $9.28. Nope. That is an 8 in the hundredths place. So my answer is B, $4.39. That's the one that has a 9 in the hundredths place. Okay? Just remember, hundredths and pennies match up. Hundredths is the standard form. Pennies is dollars form. Okay? Money form. Okay? So, place value charts are very important. So when you're showing your work, make sure that you're using place value charts. Keep it neat so that you can read everything that you're doing, okay? All right, so I'm just checking for questions. Here we go. I'm going to go ahead and move on to number 14. Oh, I'm slipping off my cushions. Okay. 14. The model below is shaded to represent a decimal. Okay. How is this decimal written in numbers and words? So we've got the picture. We need to change it to number form and word form. So let's make our place value chart. Ones, those are whole numbers, tenths, and hundredths. Okay? Oh. Do we know how many wholes we have? Well, that whole thing is filled in. So is this one. 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 6 whole grids are filled in. Hope it's okay. Sorry, I just got an error message on my computer. If you have problems seeing the live stream, you can go ahead and enter it in the chat, and then I'll check it. But right now, it seems like it's going to be okay. But anyway, we have 6 whole grids filled in. Those will represent the whole numbers. Here's our whole number section of our place value chart. So we can fill in 6 right here. Don't forget the decimal. Okay. Well, here, this one, only part of it is filled in. So that's where we're dealing with the fractions or the decimal portion. Well, how many of those little squares are there? In this grid, there are 100 of them. But how many of those 100 total pieces are filled in? Well, you can count them up individually, but I think you can count by tens. There are 30 of them filled in. 30 hundredths. Well, here's my hundredths place. So I can take my 30 and I can fill it in here. Remember what we said. If you need to, go ahead and start by cramming 2 digits into a place value. You'll immediately see that you can't do that, so you can go ahead and regroup at that time. Okay, so 30 hundredths, the 3 gets bumped up to the next place value, so this is the number in number form. So you can write it either as this, or you can write it like this. You have to understand that both of those are equivalent. 6 3/10 is the same as 6 30 hundredths. It's the same picture. It covers the same area. So they are equivalent. So you might see an answer choice like this, or you might see an answer choice like this. Both of them are correct. Okay? Well, how do we write that in word form? Well, let me get rid of this little place right here. Let's write it in word form. The decimal says and, so we're going to say the whole numbers first and whatever fraction, okay? So this is 6 and 3/10. Squeeze it. Or if we had this, we could say 6 and 30 hundredths. Both of those mean the same thing. 6 and 30 hundredths. 6 and 3/10. Both of those numbers are equivalent. Both word forms are correct, but you have to know that they both mean the same thing. Okay? That was number 14. Let me see if we've got any other questions here. Okay, we're good. We've got, nope, I don't have any questions on the Google Classroom. Okay, that's fine. All right, so let me go back to my live stream screen. Okay. Let's get rid of this. Oh, stick it out. Too short. There we go. Okay, next. Let's do number 15. The shaded models below represent 4 different decimal numbers. Okay, so now this is one number, this is one number, this is one number, this is one number. So we're going to write these as decimal numbers and then put them in order from least to greatest. Okay, so let's look at this first one. You know, in each grid, they are divided into how many pieces? 100. So we're going to count how many are colored in out of 100. And then let's fill in our place value chart. Tenths, hundredths, okay. So this is the first one, second one, third one, fourth one. I'm just going to label them A, B, C, D, just for reference when I transfer them to my place value chart. Okay. So in the first one, how many pieces out of 100 are filled in? Well, you can count by tens and then count the individual ones over. 10, 20, 30, 40, 50, 53 hundredths. The second one, 10, 20, 30, 41 hundredths. Okay. The next one, 48 hundredths. And the last one, 10, 20, 30, 40, 50, 56. Okay, 53 hundredths. Well, here's the hundredths place. So we can cram 53 in here to see that we need to regroup. So let's go ahead and regroup that 5. Don't forget my decimal. You can put in your leading 0 if you want to. That's 53 hundredths. That's A written in decimal form. Well, here we've got 41 hundredths. 41 hundredths. I've got 41 of these. Okay, well, cramming it in shows that we need to regroup. Okay, then C, 48 hundredths. 48 of these. Okay, writing it like that shows that we need to regroup. So let's regroup the 4 to the next place value. 48. And D, 56 hundredths. 56 of these. Okay, 56. I know I can regroup. Oops. The decimal goes here. So those are all my pictures changed to decimal form. Then we're going to put them in order from least to greatest. Okay, when we compare from least to greatest, we put them in a place value chart. This is our first step, which is already there. Then we're going to compare the place values from left to right. So if we start on the left-hand side, 0, 0, 0, 0. If we're putting them in order from least to greatest, can we tell from this first place value that anything is smaller than the other? No, because all of them are the same. So let's go to the next place value. We're going from least to greatest, so I'm looking for the smallest one. Okay, so between the 4s and the 5s, these two are smaller, so I'm going to look to see between these two which one is less than the other. Well, I can't compare that anymore because they are the same. So let's go to the next place value. 1, 8. Which one is less than the other? The 1. So this one goes first because it's the least. This one goes second because it is the next biggest. Well, now we've got 2 left. This one and this one. Which one is less than the other? Well, I can't compare the tens place because that's the same as that. So let's move to the hundreds. 3 and 6. Which one is smaller? 3. So this one is the next biggest. And this one is actually the biggest. So if we were to put them in order from least to greatest, the least is this one right here. Then, and then. Okay, so this will be our answer in order from least to greatest. Now on a test, the answer choices, they will give you 4 answer choices with these numbers in different orders, and you have to find the one that's in order from least to greatest. But if you go ahead and just work it out the way that we've been practicing in class, then you can just find the answer choices that matches what your work looks like. Okay? Don't be afraid to work out problems. You've got plenty of space. Okay? You can have as much scratch paper as you want. If you run out during the test, raise your hand. I'll give you some more. So don't be afraid to write things down. Don't feel like you're wasting time by doing your work. Doing your work ensures that you're getting the right answer. Okay? So I'm going to go ahead and move on. I think that was the last problem in this set. Hey, I think we're actually finished. We are finished with our test review. So I don't have any more problems to work out. I want you to remember for the test tomorrow, show all your work. Okay? Don't be afraid to work things out. How do we show our work? We're going to use place value charts. We are going to frame our answers. With a sentence, okay? Use words from the question in your sentence frame so that you know that your work is matching what the question is asking, okay? Then you can use model drawing. These are all ways you can show your work. This one, I'm going to be looking for these, okay? Going to be looking for this as well. Then, what's another? I want you to show all your work. I want you to take your time. You have 1 hour for 12 questions. So, pace yourself, okay? The test is 1 hour. You have 12 questions. The answers are multiple choice, so you are going to be filling in your Scantron sheet. But if you have 12 questions to answer within an hour, you need to make sure that you're spending the appropriate amount of time on each question. If by the time 30 minutes have passed and you're still on number 2, maybe you're spending a little bit too much time. If you get to a problem that you're absolutely stuck on, maybe skip that one, keep going, and come back to it later. Okay? So take your time, pace yourself appropriately so that you can get through all the questions within an hour. And then let's see here. Show all your work, take your time. I just want you to be really careful, okay? Study your processes for comparing and ordering, writing, changing decimals from the picture to fractions to the actual standard form decimal number. Okay, know how to add and subtract them, meaning you can use place value charts. Mostly, I want you to focus on lining up each place value, and if you need to regroup, then it's all very neatly laid out and you can do it then, okay, without making any mistakes. So, since I'm finished going through all of the questions, I'm going to go ahead and end the live stream now. I'm going to double check to make sure there's no other questions. Okay, it looks pretty good. You guys are doing all right. So I'm going to go ahead and log off. You've got, let's see here, we were able to work for an hour. Looks good. If you have any more questions and you're still preparing for the test and I haven't been able to answer your question, then you can type it into the Google Classroom forum. And if anybody else is online, they can answer your question for you. If not, then maybe try to catch me in the morning before we take our test, okay? But as soon as you come in to math on Monday, we're going to start right away, okay? So good luck preparing. I hope you all do well tomorrow. Make sure you get a good night's rest, wake up, have a good breakfast, and we'll be ready for tomorrow. All right, I'll see you.